This screen uses the animation trigger property that makes scroll trigger animations buttery smooth and incredibly easy. And this select dropdown uses a native select element styled with appearance base select. Oh, and this layout uses CSS Grid with non-uniform track sizes, which tells the user where to look first, establishing a spatial hierarchy. And we didn't build this with an AI coding agent.
Well, it's not entirely true, right?
Well, okay, yeah, but we did build it with a design agent.
This is Stitch. It's an AI design tool. You describe what you want your app to look and feel like, and it's going to generate a design backed by real HTML and Tailwind CSS.
And the most important part of this workflow is that every feature we're covering in CSS maps directly to a design principle. Grid gives us structural hierarchy, and scroll-triggered animations create a sense of continuity as the user moves through the page. And we know how to direct this design because we use the vocabulary, descriptions, and even the syntax of these CSS features.
I'm Dion, and I work on Stitch.
And I'm David, and I also work on Stitch. And today we're going to teach you how to vibe design with CSS.
So what is vibe design? It's using your intent to build a design. You describe what you want, the layout, the feel, the behavior, and the tool builds it. That's just the baseline though. What makes it more powerful is when you use your CSS vocabulary. Then your intent gets specific. Instead of saying, make it look nice, you say, use a non-uniform grid with a 2-column hero span. Instead of add some animation, you can say, bind a scale Y transform to the scroll timeline. Your CSS knowledge turns vague intent into precise direction.
And CSS is the shared language between you, design, code, and the agent. And that's the workflow that we're going to cover today. We're going to go over how to go from a CSS idea to a finished design using Stitch and the Chrome DevTools MCPs together. Then we'll start with layouts. We'll build a grid with non-uniform track sizes that showcases visual hierarchy, because who doesn't love a good grid? And after that, we'll cover how to define your visual identity and have every screen inherit from it. Colors, typography, spacing, all of it in one source of truth. Then we'll get into the weeds on the fundamentals of scroll-triggered animations to create them right from prompts. And last, and definitely not least, we'll cover appearance-based select to style a select element without any JavaScript or any libraries. And we're going to leave all of the prompts, the tools, and everything we did in the description today.
So before we start prompting, let's set up the development environment. We're using 2 MCP servers that work together, with Anti-Gravity as our IDE. First, Stitch MCP. This connects your coding agent to Stitch so it can create projects, generate screens, and edit designs programmatically. Open the Anti-Gravity MCP gallery, find Stitch, and add it. It'll ask for an API key. You can grab that from the Stitch settings page. Enter it into the Anti-Gravity UI and you're connected. Your agent can now call tools like generate screen from text, edit screens, and list screens. Second, Chrome DevTools MCP. This lets your coding agent inspect a live page in Chrome, read the DOM, check computed styles, look at the console. For this one, you just go to the GitHub repo. You copy the anti-gravity config block. Then open the MCP settings in anti-gravity. Switch to the raw config editor and paste it in. Now, one little thing to watch for, the GitHub config wraps the server in an MCP server's key. But your config probably already has that parent, so just paste the inner server block. So the workflow is 1. Design in Stitch. Prompt it with CSS concepts. 2. Inspect in Chrome. Use DevTools MCP to validate the output. And 3. Refine. Feed what you learned back into the next prompt. So design, inspect, refine. One loop. And the CSS knowledge is what makes each iteration better than the last.
All right, we have the tools set up, so let's go build something. And let's start with the layout. And a quick note about this site. It's a site about CSS features that uses those same CSS features. So it's a meta site. So every card in this grid is a topic that we're going to cover today, built with the technique that it's describing. So I prompted Stitch to have this grid structure explicitly. 4 columns, the scroll animations card spanning 2 columns, and 2 rows as the hero. The customizable select in a tall single column cell, and the secondary features filling in around it. So let's look at what came back. So here is what Stitch did. But let's actually get this into the IDE workflow. So in Stitch, I right-click the screen and I can grab this link. Then I can go into anti-gravity and I paste in that link with a prompt to get the project info. Anti-gravity talks to the Stitch MCP and returns the project details, screen IDs, and everything that I need. Now, I need to see this in a real browser so the Chrome DevTools MCP can access it. So I wrote a small CLI tool for this, which you can access at npx@_davides/stitchmcp, and you can use the serve command. And this pulls the screen HTML down locally and serves it on, well, localhost. And now that it's running locally, the Chrome DevTools MCP can access the live DOM. So let's inspect what Stitch actually generated. So if we look at the grid container, Stitch used grid template columns repeat for 1FR. And the scroll animations card landed in call span 2, row span 2, and that's the hero card. And the smaller feature cards all filled in around it. But generating a static layout's like only half the story. This is a bento grid. And what's better than a bento grid? Well, a bento grid that you can drag and drop. I wanted to see if Stitch could handle complex interactions on top of this generated code, so I asked it to make these cards draggable and reorderable. I was very specific in the prompt, telling it to use standard vanilla JavaScript and pointer events, so it just had pure performant code. And let's see how it did. Stitch generated a drag and drop bento box that lets us reorder these cards while maintaining their grid span dimensions.
So before we start prompting screens, we need to talk about the design system. In Stitch, every project has something called a DESIGN.md. Think of it like the agentic for coding agents, but for design. It defines your colors, your typography, your spacing rules, your component patterns. And when the design agent reads it, every screen it generates follows the same visual identity. Without it, each screen is an island, but with it, they all belong together. Now, when you generate a screen, Stitch will automatically create a design system for you. Here, Stitch created the design system called the Technical Curator. Every design system has a color scheme, typography hierarchy, and components visualized. There's also a written spec generated called DESIGN.md. Now, this is a readable spec that describes your visual identity and design into an agent-readable document. It contains colors with hex values and roles, typography rules, component guidelines, do's and don'ts, and you can export this file with your project, and then any downstream developer or AI agent can read it. Now let me show you why this matters for the code. When Stitch exports a screen, the design system tokens become a Tailwind CSS config. Our 4 color roles, primary, secondary, tertiary, neutral, each generate to Tailwind CSS design tokens, such as BG primary, primary container, on primary container, and tokens for fonts, like font headline, font body, and font label. And even the corner radius scale with tokens such as rounded large, rounded extra large, rounded full. Every design decision I described in plain English is now a utility class. And here's the key thing. Every screen we generate from this point forward will inherit these tokens automatically. The colors, the fonts, the spacing, they're all baked in. And of course, if I want to change something later, say I want to try a different accent color, I change it once in the design system and apply it to screens, and now everything will update. That's the CSS custom properties model. One source of truth, many consumers. Now, when you export the project, the DESIGN.md file exports with it, which means your design intent survives the handoff. Let's look at what we're building next. we're going to dive into scroll-driven animations. Watch what happens as I scroll on this page. One key thing is happening here. This thin vertical spine grew from the top of the page to the bottom, and when I scroll back, it reverses. That's a progress indicator bound directly to the scroll bar. There's no JavaScript scroll listeners. It's all pure CSS. One property is doing all of the work here. It's the scroll timeline. Here's the CSS that makes it work. A fixed position element with a scale Y keyframe that goes from 0 to 1. The magic is the rule animation timeline scroll. That single declaration binds the animation progress to the scroll position instead of time. And transform origin top center ensures it grows downward. Now let's build this in Stitch. The first step is the document structure. I'm prompting Stitch to create an alternating 2-column layout. 4 sections, each a 2-column grid, alternating which side gets prose and which gets the code block. There's no animations yet. This is just the skeleton. Now let's inspect the result using the Chrome DevTools. Anti-gravity will get the screen ID and pull it up in Chrome. The skeleton looks good. So now let's pull in some animation. This is step 2, the scroll-linked progress spine. I want that thin vertical line fixed to the center of the viewport, so it grows as the user scrolls. I'm going to ask my coding agent to generate a prompt that leverages this CSS. I'll specify using animation timeline scroll with a root block axis mapping the scale transform directly to the scroll percentage. And I'll make sure to specify transform origin top center so it scales downward from the origin rather than the center. Let's see what it gives us. Before I run the prompt, look at what anti-gravity came back with. That agent understood the intent and broke it down into exactly 2 pieces. First, one empty div, editorial spine, as a direct child of the body. That's really important because it can't be nested inside a relatively positioned container or the fixed positioning breaks. Second, the CSS. The agent centered the line with left 50%, margin left minus 0.5 pixels instead of translate X. And that's a really good choice because it keeps the transform property completely free for scale Y. Then the 3 lines that matter. Transform origin top center animation, spine draw linear, and animation timeline scroll root block. And notice what the agent called out about performance. Because the only properties changing are opacity and transform, the browser hands this to the compositor thread. 0 JavaScript listeners, 0 layout recalculations. Just like the original, when I scroll back, it tracks my scroll position continuously, using the scroll timeline. And the prompt that built it was specific about the mechanics, the keyframes, and the timeline type. The CSS vocabulary is what made the prompts precise enough to get the right result.
Okay, last demo. Look at the left side of the screen. That's a regular native select element. It has a default system font, a default border, an OS render drop-down arrow that you can't change. And for decades, this has been one of the most frustrating elements in HTML to style. I mean, people built like entire JavaScript component libraries just to get a decent looking drop-down. But now, let's look at the right side. This is the same element. It's a real select, but it's styled with appearance-based select. It has a custom background, custom icon, custom typography, and that blue bottom border. Everything you see here is pure CSS on a native form element. And that's what we're going to build. So here's how it works. One CSS property, appearance-based select. And that single declaration tells the browser to stop rendering its own Chrome and hand control over to you. Now, the select is just a box. And I mean, you can put anything in a box. So you can set the border, you can set the font, everything you do with any other element. And the browser still handles all the accessibility and keyboard behavior. You just own the visuals. So let's build that right side. I'm telling Stitch exactly what I want, setting appearance base select, the warm gray background, the blue bottom border, and the layers icon. And I'm being really specific about the design tokens, because the more precise the prompt, the closer that Stitch is going to get on the first try. And here it is. Remember that right side of the split screen? Well, this is it, running live. It's the same thing, that warm gray background, the blue accent border, the layers icon, all generated from that one prompt. And if you tap to it from the keyboard, it just works. And you can arrow through the options and the focus ring is there, because it's just a native select that looks like a custom component. And it's all just CSS.
So your CSS knowledge isn't just for implementation anymore. It's your design vocabulary. Every feature you learn, from grid to scroll-driven animations, custom select styling, custom properties, clip path masking, you name it, it gives you a new word in that vocabulary.
And don't forget to check the description for all the links and tools and prompts. And if you have any questions, I will literally be the first comment on this talk. So, you can just ask.
So thank you so much for spending this time with us. And please go design something.
And see you in the comments.